Good morning, students. Uh, as you have got electromagnetic wave theory, which gives the properties of light, but there are some drawbacks of electromagnetic wave theory. The main two drawbacks of electromagnetic wave theory: number one, it cannot explain about the phenomenon which is called black body radiation. Electromagnetic wave theory cannot explain about the phenomenon of black body radiation. Another drawback, electromagnetic wave theory cannot explain about the photoelectric effect. These two phenomena, one is black body radiation and one is photoelectric effect. These two phenomena is the phenomenon of the light, and these two phenomena cannot be explained by electromagnetic wave theory, and these two are the main drawbacks of electromagnetic wave theory. Now you have to do what is black body radiation, what is photoelectric effect, individually you have to do. So now I will tell you what is black body radiation. If you want to know about black body radiation, when a substance with high melting point, the substance whose melting point is very high, that type of substance you have to consider. When a substance with high melting point, for example, you can take iron bar, its melting point is very high, is heated, it becomes red. When the iron is heated, it turns to red color. On further heating, it goes to yellow, then white, and finally it gives blue light. When some high melting point substances you heated, then after heating you can see the red color. On further heating, the color continuously going on changing. Initially you can see red, then it goes to yellow, then it becomes white, and finally you will get the blue color light if you heat the high melting point substances. Now, why this type of substance gives different colors on heating? If the substance being heated is a black body, then it can absorb or emit all kind of radiation. The radiation emitted from a black body, is called black body radiation. Simple example, in summer season, when you use some black dresses, you feel more hotter, na? Why? Because it can absorb the light. So when a black substance, a perfectly black substance, when you heat it, then the black substance have the property that it can absorb any kind of radiation of different wavelength, different frequency radiation, and it can emit the radiation also. The radiation emitted from a black body is called the black body radiation. Now, why a substance when heated it shows different colors? Because as the substance is going on heating, the energy going on increasing. Heat is one form of energy. As the energy going on increasing, the frequency also going on increasing. There is a relation. Energy is directly proportional to the nu. You will get later. I mean, the energy of radiation is directly proportional to the frequency of the radiation. And when you remove the proportional sign, a constant, you will get h, which is called Planck constant. You will get later. Now, as the substance is going on heating, the energy of the energy supplied is going on increasing, and that is why the frequency of the substance also going on increasing, and that is why as the frequency increases, the color also continuously going on increasing. And that is why first time you can see red color, then yellow, then blue color, like that. But this concept cannot be explained by the electromagnetic wave theory. So this is one of the drawback of electromagnetic wave theory. And second drawback, which is called photoelectric effect. This is very important for exam. So now what is photoelectric effect? Now first time I will explain what is photoelectric effect. First time I will explain what is photoelectric effect. Suppose this is a metal block and this is the surface of the metal. For example, you know sodium. Sodium is a metal and its atomic number is 11, you know. Since the atomic number is 11, its electronic configuration will be 281. This electron is called valence electron, you know. And you know every metal contains some loosely bonded electron, I mean the valence electron. And that valence electron is always present at the surface of the metal. So this is nothing, this is the valence electron of the metal. So every metal contains this type of loosely bonded electron, and that electron will be present at the surface of the metal. Now, in this metal, if a radiation falls on the surface of the metal, then the electron present in the surface, the electron may be ejected from the surface of the metal, and this electron is called photoelectron, and the effect is called photoelectric effect. So when a radiation of definite frequency falls on the surface of a metal, then the electron from the surface may be ejected from the metal, and that electron is called, I mean the ejected electron is called photoelectron, and the phenomenon is called photoelectric effect. So I'll give you the definition, then you can understand it.